My name is Stefan Zivkovic and welcome to my Grade 12 Advanced Functions Math CCT. In this presentation, I will be explaining question 11, page 205 in the Nelson Advanced Functions textbook. Hope you enjoy my presentation as much as I enjoyed making it. And now, time for some math. Question 11 on page 205 reads, the Sickle family members are very competitive card players. They keep score using a complicated system that incorporates positives and negatives. My score for the last game night could be modeled by the function Sx equals x times x minus 4 times x minus 6, where x is less than 10. As you can most likely tell, this question revolves around the function x times x minus 4 times x minus 6. This function is a polynomial, which we learned how to solve in Unit 2 of Advanced Functions. Part A of question 11 asks, after which game was Maya's score equal to 0? To answer this question, we must know at which point the cubic function representing Maya's score for the last game night crosses over the x-axis, therefore meaning that it is equal to 0. Using the knowledge we learned in Unit 2 of Advanced Functions, I know that our cubic function is equal to 0 when x is equal to one of its roots. To find out the roots of x, we must split the function up into three parts. We can split it up into x, x minus 4, and x minus 6. Now, we must figure out what sets each one of these sections to 0. The first one's easy, as x equals 0, therefore 0 is one of our roots. Now, x minus 4 equals 0. To solve this, we just bring the 4 over, giving us x equals 4. Therefore, 4 is another one of our roots. And for the last part, x minus 6 equals 0. Bring the negative 6 over, x equals 6. Meaning that our last root is 6. So the following roots are x equals 0, x equals 4, and x equals 6. Therefore, our cubic function is equal to 0 when x is equal to 0, x is equal to 4, and x is equal to 6. To prove this, let's set those values back in as x. First off, we have 0 times 0 minus 4 times 0 minus 6. And 0 times anything equals 0, therefore the answer is 0, which is correct. Now let's try the next one. Let's sub 4 in. 4 times 4 minus 4 times 4 minus 6 gives us 4 times 0 times negative 2. And once again, 0 times anything equals 0, so when x is 4, the function is at 0 as well. Now let's try 6. 6 times 6 minus 4 times 6 minus 6. Once again, we have 6 times 2 times 0. And once again, 0 times anything equals 0. So when the x is equal to 6, the function is equal to 0. Therefore, to conclude, my score is equal to 0 at the start of the game and after the 4th and 6th game. Now for part B of the question, where it asks, after which game was Maya's score -5? Part B is very similar to part A, except there's a key step that we must do first. And that step is to set the function equal to -5. We're doing this because we want to figure out at what x value and game Maya's score was equal to -5. Our next step would be to FOIL out the right side, giving us -5 equals x cubed minus 10x squared plus 24x. After this, we are going to bring over the -5 to give us 0 equals x cubed minus 10x squared plus 24x plus 5. We're doing this to set the function equal to 0 so that now we can solve for the roots. To solve for the roots, we must first look at the constant of the equation. With this, we could use its factors and guess and check to figure out what the first root of this equation would be. So let's start off with 5. Let's 0 equals 5 cubed minus 10 times 5 squared plus 24 times 5 plus 5. After this gives us 0 equals 125 minus 250 plus 120 plus 5. And after collecting like terms, we could see that the equation does equal 0. Now that we know that x minus 5 is one of the factors and 5 is one of the roots, we could use this to do synthetic division, setting x minus 5 as the divisor and the values of our function up at the top, giving us 1, negative 10, plus 24, and positive 5. Now we just synthetically divide, bring down the 1, multiplying by 5, giving us 5, adding these two together, giving us negative 5. Repeat the process, giving us negative 25, and we add them, giving us negative 1, and then once again, negative 1 times 5 equals negative 5, leaving us with 0. Therefore proving that x minus 5 is a factor, and also giving us the quadratic function of x squared minus 5x minus 1. To find our other two roots, we must now factor the quadratic, leaving us with our first factor of x minus 5, x plus 0.193, and x minus 5.193.
Therefore, we know my score is equal to negative 5 after the 5th game, as this is the only root which is a whole number. As there are two other roots, but they are decimals, therefore we reject the answers, as it must be precise and it must be after a certain game. Now for part C of the question, which asks, after which game was Maya's score equal to 16?
Part C is the exact same as part B, except now for looking at what game Maya's score was equal to negative 5, we're looking for after which game was Maya's score equal to 16. Therefore, we follow the exact same steps of setting the equation equal to 16. And now I'll skip a few steps, but we FOIL out the right side, giving us 16 equals x squared minus 10x cubed plus 24x, and then once again bring the 16 over, giving us 0, x cubed minus 10x squared plus 24x minus 16, and then once again we must now find the roots of this function. Therefore we look at the factors once again of the constant, and for this one let's choose 2 as the first option, and we'll sub that in. 0 equals 2 cubed minus 10 times 2 squared plus 24 times 2 minus 16, leaving us with 0 equals 8 minus 40 plus 48 minus 16. And then once again, once we add like terms, we see that 0 does in fact equal 0. Therefore, x minus 2 is one of the factors and 2 is the root, also meaning that after the second game, Maya's score is equal to 16. Now that we know that x minus 2 is one of the factors, we could use synthetic division once again. Setting x minus 2 as the divisor, and then plugging in the values, which is 1, negative 10, positive 24, and negative 16. And then once again, do the steps of synthetic division, break down. 1 times 2 equals 2, then we add, giving us 8. 8 times 2 equals negative 8 times 2 times negative 8 equals negative 16, and we add, giving us 8 once again, and then 8 times 2 equals 16, giving us 0. Once again, proving that x minus 2 is a factor, and giving us the quadratic of x squared minus 8x plus 8 as our other factor. To break this apart further even more, we must factor this quadratic, giving us x minus 2, x minus 1.72, and times x minus 6.828. And once again, since x minus 2, or 2, is the only root, which is a whole number, we reject the other two answers. This means that x is equal to 2, x is equal to 1.72, and x is equal to 6.828. Therefore, Maya's score is equal to 16 after the second game, as it is the only whole number value for x. Now time for part B, where the question states, draw a sketch of the graph Sx if xer and explain why this graph is not a good model to represent Maya's score during this game night. Therefore, meaning that x is no longer restricted. Using my sketch of the function that models Maya's score throughout her game night, where x is unrestricted, we could see that this is not an accurate representation of her score, as by even the 11th game, her score is as high as 396 points, which judging by the previous increments is most likely impossible, or very, very unlikely. Furthermore, if we continue into the 11th and 12th and 13th games and anything past that, we see that her score is only increasing by a higher and higher amount, meaning that she is winning every single game and not losing a single point, which is also very unlikely or impossible. Therefore, to conclude, when x is unrestricted, this graph does not model her score properly, as it both exaggerates her scores and also states that she wins every single round after the 5th game. Now to use the electronic version of the graph modeling Maya's score for her game night to double check all the answers in the previous parts. First off with part A, where we stated that Maya's score was equal to 0 before the first game, after the 4th game, and after the 6th game, where if we set the equation equal to 0, we can see that it in fact does equal 0, 4, and 6. Now on to part B, where we stated that after the 5th game, Maya's score was equal to -5, where if we set the equation equal to -5, we could see that it is indeed equal to -5 after the 5th game. Now for part C, where we stated that Maya's score was equal to 16 after the 2nd game, where also when we set the equation equal to 16, we could see that we do get the value, or we do get a line crossing 2, meaning that her score does indeed equal 16 at that point. And after looking at the graph, we could also see that there are no other x values located on whole numbers. Therefore, by using Desnos, I have proved that all my answers are indeed correct and match the following graph.